joint work with
two researchers from the University of Bern. That's actually a mistake, I'm sorry, University of Bern and University of St. Gallen, not University of Basel. And I am myself a researcher at the University of Zurich. And the topic of this project is how classroom rank in mathematics subjects, or how a student is positioned relative to his peers in the class, affect career choices, occupational choices, and other long-term outcome. Now, why on a first place we decided to look at occupational choice, and it will become a bit clearer later when I tell you a bit how the Swiss educational system is structured. But of course, occupational choice, so the field where you decide to work at the beginning of your career, has a strong impact on your later in life labor market outcome and on a series of indicators of well-being, starting from earnings, of course, worker satisfaction, and so far and so on. So it's an important indicator, basically, of how you will perform on the labor market. And previous research has identified and discussed different factors that might affect this occupational and career choices in life, starting, of course, from more economic-based considerations, so the likelihood of having a certain type of earnings, some job characteristics, of course, so characteristics associated to the field where a person wants to work, individual related characteristics in terms of skills and ability of the person itself. But a more recent set of works that is growing in number, it's so far not so huge, but it's growing in numbers in the last year, relate to basically looking at how characteristics of the school environment affect occupational and career choices. And in this sense, like a few papers that looked, for example, at how characteristics of the teachers in the specific schools affect students' decision, or how characteristics of the classroom mates of the students affect their decision. So our project is placed, let's say, within this branch of the literature, in the sense that we want to look at one specific school environment, which is the relative rank in mathematics within one classroom, and see how these matter for occupational choice. And of course, let's say the first thing that one may ask and wonder is why we think and we believe that classroom rank might at all affect outcome at the individual level, right? And in a sense, we see quite some research that show how rank and your comparison with peers in your group affect intrinsically both beliefs and behavior, not only in the educational setting, but in the educational setting. So in the school level, you can think that, for example, schools do not have a perfect information about their own ability, and they somewhat rely in the comparison with their peers to understand how good they are, how well they are doing, what are their chances later in life, what they can do, and so far and so on. So the comparison with their peer is probably an important chunk of their decision. So that basically. Okay. Microphone is working. Also in the other room. So that we can think that not only actual ability and actual skills of the student matter for their choices and their outcomes, but also the perceived ability. So how good and how well performing they perceive themselves as compared to their peers matter to select into specific occupation that may require skill in specific subjects. So the point, or let's say a bit the reason why then we started this project and what was there at the beginning in our reasoning was that if occupational choices are influenced by school environment and specifically by your comparison you perform with your peers, then this comparison, your perception of your own skill may lead you to what is not the most efficient occupational choice or labor market choice, because indeed you base your choice on something that is your perceived ability, not your actual ability. So from an economic perspective, so to say, we may see choices that are not efficient because based on perceptions rather than on reality. To cut it short, basically what we are doing in this paper is then using this ordinal classroom rank in mathematics, and we focus on mathematics because it has been by now proven that it's a subject that has like a huge relevance in later labor market outcomes. So how this rank in math within the classroom in compulsory school, the last year of compulsory school, affect occupational choices, and I will go back on how we define that later. Labor market outcomes in terms of earnings and employment probability, and further human capital investment in tertiary education or well beyond compulsory schooling, basically. And how we do that, so how we will perform our analysis, is basically employing regression models that exploit the fact that student who has the exact same ability, which we measure through the PISA test. So student with the exact same ability in mathematics may have a very different ranking in the classroom just because of how they have been more or less randomly assigned to classroom where the ability distribution is different, right?
Un po', ma lei sta parlando al microfono?
Okay, so we explored this variation in basically the different ability distribution across different classes and how this influences basically the relative positioning of a given student with the same, which may have a completely different ranking in a different class because of like similar absolute ability, let's say. And we do that thanks to a very nice set of data that is available, unfortunately, just for one cohort, but these are Swiss data that start from PISA 2012, so like the Swiss sample of PISA 2012, which has then have then been linked to national student registry data, tax earnings data, and so far and so on. Again, I will go back on the data, but since we are talking about how integrating data of different nature, that's quite a nice data set. But in all fairness, also the Swiss could just do it for 1 year, so it would have been nicer if it was like a persistent effort, so to say. So also, as a brief outlook of what we find, so you know about it, regardless of where I get to with the presentation. Basically, we find indeed that classroom rank in math has an impact on career choice. So we find that being positioned higher within a classroom in terms of ranks contributes to a higher likelihood of selecting into an occupation with a heavier STEM intensity. And this is also linked with likelihood of having higher earnings 6-7 years after completing compulsory education, which is to some extent consistent with the idea that STEM occupations are often yielding higher when we try and understand what are the possible mechanisms that that explain this association between rank and earning/occupational choices, we find within the PISA survey that rank is also associated with, let's say, more behavioral measures of interest in math, eagerness to provide effort in math, and so far and so on. So it seems that what rank is affecting is indeed the general attitude towards math and the eagerness of students to put effort and invest in this field, in this subfield. Whereas as far as concerned this occupational mismatch, so this thing that I was mentioning at the beginning, that having a misperception of what are your actual ability, what are your perceived ability as compared to your actual ability may lead to an inefficient allocation of your resources, so an inefficient choice of occupation in this case. We do not find that rank is associated indeed with this occupational mismatch. So I will go more in the specific of it, but basically like we do not find that students who pick an occupation that it's more heavily STEM intense, after a few years drop out from or like change field of occupation, which would be an indication that they are no longer convinced with their initial choice. So all in all, we find that school environment, specifically rank in the class, has a lasting effect on labor market outcomes, further education, occupational choices, whereas we do not find evidence that rank has an effect on inefficient choices in occupation. Now, this was basically the paper. Now I can tell you a bit more what we did and how we did it. And I take a step back in the sense that the Swiss educational system is slightly different actually hugely different from the Italian one. It's similar to the German or the Austrian one, if you're more familiar with it. Basically, the years of compulsory schooling are not dramatically different. So students go to kindergarten, primary school, and then lower secondary school, so the equivalent of our school media. But already in the lower secondary school, they are tracked into higher and lower ability. And now we observe them exactly in between, so at the end of this first yellow block, in the sense that we observe them at 15 years old, so at the very end of compulsory school. At the very end of compulsory school, they can choose basically whether to opt for fully school-based general education, so what we would think of as licei. So that's like a classical school, 5 days a week in school and so on. Or what is actually the majority of what happens in Switzerland, that they can opt for a vocational education, and that's like the prevalent choice actually in Switzerland. Now, vocational education is different than in Italy in the sense that it's structured through this so-called dual system, in the sense that students basically choose, while choosing vocational education, they choose a specific occupation out of over 250 occupations, so extremely specific. So they decide they want to be gardener, florist, they want to be polymechanic, they want to be nurses, whatever. And then once the school starts, 1-2 days a week are indeed in like formal education, so in a vocational school, like from the classes and so on. And the remaining 3-4 days a week are in an on-job apprenticeship. So it's an extremely practically oriented and professionalized type of education. They basically learn a job like right from the start, right at 16 years old. And again, this is like what the majority, so we are talking about like 2/3 of every cohort of student entering secondary, so upper secondary education that picks vocational education. And now going to the data, and I should have mentioned something. That's why actually we, in the analysis, we focus only on vocational education students, because about these students we have basically information on the exact occupations, on the exact career basically they project themselves into at 16 years old, 16 years of age. And so what we do is taking the Swiss section of the PISA 2012 data, and it's like that's a data set that you probably all know pretty well. We have information about test score, math, reading, and science. We have a lot of information on the socio-demographic background, family characteristics, and so far and so on. And because the 2012 had a specific focus on math, we also have this like few information on beliefs, attitude, and so on specifically the subject of mathematics. And then this is linked with, as I mentioned, student registry data, so which means that we have full information on all the PISA participants basically of everything they did within the Swiss educational system until 2020, so where they went after compulsory school, what region they enrolled, what school they picked, what occupation they picked in this case, and so on. So these are similar to the national register data that they were mentioned before in Italy. Then these are also linked with the earning records from the tax authority, so we have information about the earnings and the employment status of this individual, all of this up until 2020. And then that's next and further finally linked with some information on the skill requirement of this training occupation, so this like vocational occupation that the student did. And that's something that the, I think the Swiss Statistical Office did, but basically for each of these over 250 occupations, they established that, okay, this specific occupation require this amount or this type of skills in mathematics rather than in foreign languages rather than in that. So thanks to this skill requirement data, we can basically measure or like come up with some measurement of the STEM intensity of each given occupation. Okay. Then how do we measure rank, which is basically the main variable of interest in our model? As I mentioned, we measure the relative ranking, not the absolute, so the relative ranking in class in a percentile form, so that eventually our capital RIC, so the rank of student I in classroom C, it's basically a number that goes from 0 for lowest ranking to 1 highest ranking, regardless of the regardless for the actual size of the class. And what we have within, so what we do first is basically positioning the student in an absolute rank dimension. That's the small n, so n of IC. So we position student within one classroom, like going from 1 to the number of students that are in the classroom, and then with this like absolute ranking position, we compute our math percentile rank. So again, that's a measure. So our math percentile rank goes from 0 to 1, and we use that, as I mentioned, in a regression where the outcome, so our left-hand side variable is a long-term outcome. As I mentioned, we will primarily look at the occupation they choose, that's one outcome, at the earnings, 6-7 years after compulsory schooling, and at the different measures that basically give us an information about the probability of retraining or further education, enrolling in higher education, and so on and so on. And as I mentioned, our variable of interest is the capital R, so we will be interested in looking at the beta coefficient. And then we have, because of PISA, we have a lot of very nice information we can condition on in our regression. We control, of course, for the absolute ability of the student, so that's the let's say, raw PISA score, because of course this has an impact itself. And we control with some polynomial, to be sure that we also catch, let's say, different distribution of disability. And again, the old variations or the old identification come from the fact that students with the same ability could have very different rank just because of the classroom they get assigned. And that's the very first result. So here we look at the probability of enrolling into or like choosing an occupation that has that is heavier on the STEM side. So STEM intensity of the occupation is the dependent variable. And we see that basically ranking at the top of the classroom as opposed to the bottom implies a higher likelihood of roughly 9 percentage points of enrolling in or like choosing an occupation after compulsory schooling that is more STEM intense. And this result is quite robust. If you have specific doubts, you can ask, but we do a bunch of checks, and the results seem to be there, so not driven for at least the thing we can observe for. And we observe some heterogeneity, which is interesting, and more specifically we see that there is some nonlinear effect, so rank seems to be more relevant and important for students who are in the lower segment of the distribution, so the lower performing students, and so meaning they rely more heavily on perceived ability rather than actual one. And we also find a role for parental education in the sense that students with more educated parents rely less on rank. So it seems that parents, or like our assumption is, or like understanding is that parents with lower education may be more likely to, again, heavily rely on perceived ability, and so look at the classmates of their kids to advise them and put them on track for the following education decision. And as I was mentioning at the beginning, we see that math rank as measured in the 9th grade, so at 15 years old. It's also highly linked with this like confidence in math ability, interest in math, eagerness to put effort in math, and so on. So we think that these may be the channel basically through which then the subsequent occupational and labor market choices, etc., are made. So going quickly, as I mentioned, also we see an impact of rank on student earnings. So being in the higher, like being placed higher in the class is linked with a annual earning of roughly now 9,000 francs. And we also observe that students that have a higher ranking are more likely to invest in further human capital, so enroll in institution of tertiary education, for example. They are less likely to drop out, and they're also less likely, or like not likely actually, to switch a type of occupation. And again, this goes in the direction I was telling at the beginning, that there is probably, or we do not find evidence, at least in our data of this possible mismatch between actual ability, perceivability, and choices. And I think I'm running out of time, so I will just go to the final slide. So to wrap up, we studied the effect of ordinal rank in the class for the subject of mathematics. We find that this is a measure of school environment, peer environment that is relevant for subsequent occupational choice, labor market earnings, and further human capital investment. Whereas we do not find that classroom rank is associated with a higher probability to retrain and change occupation once the initial decision is made. So this goes a bit in the opposite direction of what we thought we will see, in the sense of finding some inefficiency in the occupational choices because of rank. But there is no evidence for that, basically.
Thank you.